Welcome to Sravz technical series. In today's session, we'll discuss the covariance analysis which can be done on portfolios in the Sravz UI. So this is the documentation page. So before we go through the discussion, I'll quickly go how we can do the covariance analysis on in the UI. As I'll switch to the Sravz UI. So the covariance analysis page is available in the analytics section. So once you click on the hamburger bar and analytics, then there's covariance analysis. So by nature, covariance analysis can be done on multiple assets. So it has to be done on a portfolio. So in Sravz UI, we already created some portfolios here. So in today's session, we'll just reuse these existing portfolios. And in a later session, we'll show how to create portfolios by combining multiple assets into a single portfolio. So to perform covariance analysis, click on the details icon on a portfolio. For example, I have a portfolio here, S&P 50%, 50% in US 500 and 50% in S&P 500. So it's a weighted portfolio of 50% in US 500 and 50% in S&P 500. This portfolio is 45% in US 500, 45% in S&P 500 and 10% in gold. So overall, we have to get 100% weightage. Likewise, I have two portfolios here. It's a long US 100. So we are long NASDAQ 100 and short S&P 500. So the net weight is 0 for this one because we are long and short equal dollar amount. In this portfolio, we are long US 100 and short Russell 2000 equal amount in dollar cost. So once we click on the icon, after a while it will show the covariance analysis. So we generated the covariance analysis of 50% NASDAQ 100 and 50% S&P 500. It's an equal weighted portfolio in terms of dollar cost. So this is the covariance metrics. So we show the covariance metrics in this format where we have NASDAQ 100 on the x-axis and NASDAQ 100 on the y-axis. The covariance metrics between these two is negligible because it's the same asset, so it's almost close to 0. Also, NASDAQ 100 and S&P 500 have somewhat covariance, but not that much. And then the correlation is 1 for the same asset. So NASDAQ 100 has a correlation of 1. And S&P 500 and NASDAQ 100 have a correlation of close to 0.89. So close to 1. So they almost move in tandem, as you know, because NASDAQ top 10 have major weightage in S&P 500 to almost 25%. So they move somewhat together in the same direction. So we'll go through the math involved with the correlation and covariance. So the covariance matrix displays the adjusted close versus daily returns, which we did here. Covariance matrix, adjusted close versus daily returns. It's a statistical measure of directional relationship between assets. Positive covariance implies assets move in the same direction. Negative means negative covariance implies assets move in opposite direction. So in our case, we have positive covariance here of, say for example, S&P 500 and NASDAQ 100. They have a positive covariance. So if you go to the plot between those two, this is NASDAQ 100, S&P 500. The covariance is positive. They go in the same direction. So when S&P goes this direction and NASDAQ goes upway in this direction, the line is almost 45%. So they move in the same direction. The spread, so covariance gives the spread The covariance gives the orientation of the spread. So when S&P 500 moves in this direction, Nasdaq moves in the upward direction, the combined portfolio moves together with both of them. So it's at a 45-degree angle. Sometimes an asset can pull the rest of the assets because that is a dominant asset. In that case, the covariance is determined by that strongly moving asset. So the variance of a single random variable is given by this formula: xi minus x bar. X bar is the average, and then we divide by n minus 1 to create an unbiased variance. So it's less than, ideally this should be n, but we do n minus 1 to create an unbiased variance calculation. Then covariance of two random variables is given by this formula: xi minus x bar, yi minus y bar. In our case, that would be, for example, if x is S&P 500, then it would be xi, one observation of S&P 500 with the average of S&P 500. Similarly, this is Nasdaq 100 with the average. Covariance matrix calculation is done this way in this formula. And if there are only two assets, then it's a two-dimensional covariance matrix. In the time series analysis, if you remember, we did a unitary root test to check if a time series is a random walk. Using covariance metrics, we can also determine if a portfolio is a random walk. A portfolio is a random walk if none of the assets are correlated to each other. Their variance, covariance. So individual variance is 1 and the mean is 0. Then this becomes a identity matrix. If it's an identity matrix where this is 1, 1, and covariance of y and x is 0, this becomes a identity matrix. In that case, you can say that there's no covariance between the assets in the portfolio, so it's a white noise. Now, covariance gives the relative direction in which the assets move. But if you want to have a quantitative metric, then we use correlation metrics. It shows the relative strength. Correlation shows the strength of the relationship, and it is measured between -1 and 1. So correlation is more standard way of deciding if two or more assets have a relation between each other and how strong it is. If it is 1, then they strongly move in the same direction. If it is -1, they move in the opposite direction. 0, they move randomly. And then these are some other plots we plot here. For example, we have this expected return versus risk. If you look here, for example, risk, which is standard deviation, sigma, is on the y-axis and the expected returns on the x-axis. So Nasdaq has higher risk for more returns because it's more tech oriented and it's only 100 stocks. S&P 500, since it's 500 stocks and it is more spread out, not just tech oriented, it gives lower returns but lower risk. So when we join these two with a 50-50 basis, then maybe our portfolio will be somewhere in between here. So that way we have more returns but lower risk, which is better than having pure exposure to Nasdaq 100 or S&P 500. So the expected return versus risk plot shows where each asset in the portfolio lies. And these standard deviation, these normal distribution plots will be discussed in a separate video where we can check the kurtosses, the tails, how much risk is in the tails, if there are fat tails or pure normal distribution, etc. So we'll discuss that in a next video. So with that, I'll conclude today's session. So to do covariance analysis, you have to click on the hamburger bar, then the analytics page, and the covariance analysis link is here. So thank you for watching. If you have any questions, please reach out either in the discussion tab here, in the discussion section, or in the YouTube channel.